Good afternoon, everyone. Thank you very much for being here and attending this epic new product release. So I'm Jeremy Picot-Clemente. I'm a technology manager, technology specialist at Epic, and I will moderate this session. So it's a 1 hour of full of presentation. We'll have five speakers today, introducing their new product, new soft, and I will introduce you, to the agenda. So we'll start with Alpes lasers with Mickael Nehlig. We'll continue with Finetech Mohamad Bahr, Inphocal Robert van Tankeren, Mapsi David Cardador Maza, and we'll finish this online meeting with Wave Photonics and Matthew Anderson. So if you have any question during the meeting after each presentation, we keep some time, 2-3 minutes for questions. So feel free to raise your hand through Zoom. And if you want to be introduced to one of the speakers of today's meeting, feel free to contact us. You can find my email address on the top here, and I will be pleased to do the introduction. So thank you again, and let's start with our first speaker of the day, Mickael Nehlig from Alpes Laser. So Mickael, I will stop sharing and I will give you the floor.
Okay, hello, nice to meet you. So I'm trying to share right now. Okay, can you see my screen?
Yes, all good.
Okay, let's go. So Alpes Lasers, we are a company in the heart of Switzerland, and we manufacture mid-infrared lasers. And I'm here to introduce you the newborn, the glider. So the glider is basically a mid-infrared laser platform for advanced spectroscopic sensing. The glider is powered by cascade laser, QCL and ICL laser chip set in external cavity. So that's why I mentioned EC QCL and EC ICL. So this lasers is based on our strong experience, and it is the second generation of this kind of system at Alpes. The main benefits of this external cavity architecture is the wide tunability of the lasers and the narrow band. So on the right, you have a quick example of the principle. The external cavity QCL can emit different type of wavelengths that you can tune with narrowband, and it hits the analyte, and by analyzing the spectrum you can find the concentration of the molecule that you want to measure inside the analyte. So you would say, why mid-infrared? It's because this region of the spectrum is really interesting, because most of organic molecules has a strong spectral signature. So about the mid-infrared, we talk between 3 and 13 microns. You have the conversion here in wave number, and you can see that many absorption of molecules here, and it gives a high chemical specificity. That means two different molecules will have two distinct absorption spectrum that make the sensing easier, and it can be used in different media, even complex like water or biotissue. So let's talk about figures and the key specification of the glider. Has a laser source, so we say that it's a wide coverage with high power as well, and high modularity. That means the user can choose the laser chip that he wants to put inside. He can add one if he wants to extend the tunability range or remove one, so it's very flexible. The tunability can reach 6 micron gapless thanks to the 4 laser chips configuration. So this is the configuration with the big box here. We also have the compact version with 1 laser chip inside. It is fast, accurate, and engineered for integration, because the design has been ruggedized and has options like fiber output, just right here, and available with OEM version. So very important to understand that the glider has a special positioning on the market because most of our competitors are doing either laser source or analyzer. The glider is right in between. Thanks to the integrated acquisition capabilities. So let's take an example with the drawing. So you have the glider here, the rear side, that can emit the laser light with different wavelengths, hit the analyte, hit the detector, and the signal of the detector can be synchronized with the emitted wavelengths thanks to the data acquisition module and the high level controller. And at the end, with all this integrated module, you can plot absorption spectrum. So you don't need to have many devices around the glider. So it makes the setup very easy and simplify it by keep the application variables open. That means the user can choose the kind of detector he wants to use. So that make the system easy and flexible at the same time. About the application, I see two ways to use the glider. First, has a discovery system, it's much for R&D when the user wants to explore unknown compounds, or the other way is the, let's say, the industrial way as online and in situ analysis thanks to the real-time measurements. And the glider is already field proven with full versatility used in diverse projects. One recent one is the wastewater plant in Athens for water quality monitoring. So we enter into the field environment, which is very important with for the glider because you can measure many pollutants, microplastics, and PFAS because they has spectral signature in the mid-infrared. Life science is also a big thing for the glider, especially for blood and biomarkers analysis. Um, you can also do hyperspectral cell imaging, and of course, industry, for example, chemical process control like polymerization or material characterization. So you would say FTIR can already do this, but it's important to understand the strong difference between ECQCL and FTIR. I selected here 5 criteria. First is sensitivity. Thanks to the high power of the lasers, the signal to noise ratio is much higher. So at the end, the sensitivity is better. Selectivity is also really good thanks to the monochromatic narrow band of the laser. You can easily target the absorption line of the molecules. Speed, because it makes fast scan and real-time measurement possible. Portability, thanks to the compact version and OEM version, and less instruments around the glider. So at the end, I would say that the most important criteria is versatility, because you don't need the user does not need to make a strong simple preparation. It can be directly usable in different media, gases, liquids, thick films, solids, suitable for industrial application when FTIR is mostly for for labs. And to end this presentation, I will quote the head of sales of Alpes Lasers that said, the glider is more than a laser source. It is a mature mid-infrared photonic building block ready to be embedded in the next generation of analytic instruments. So thank you for your attention. And I'm Mickael Nehlig, and I'm here to hear your questions.
Thank you, Mickael. Any question? For Mickael, you can raise your hand through Zoom. Mickael, you mentioned some application in for industrial application, sorry.
Yeah.
How much this product can be suitable for harsh environment?
Which kind of harsh condition?
I mean, like if you add it on the, on a process line, for example, to
Okay.
need IR measurement. Is it possible?
So it
Yeah.
yes, because the housing is dust protected if there is a dust, and if the environment is very harsh, the best way is to use a fiber. So with the fiber, you can depot the light, and we can. It's not available right now, but we have the fiber option, and the next option is complete probe.
Okay.
So the idea is to combine the the light that goes into the media and the light that goes back into the glider. So all the electronics and laser chip spots can be put into a safe environment, and into the harsh environment, it will be just the probe of the fiber.
Okay. Good. Okay. So thank you again, Mickael, for your presentation. Thank you.
You're welcome.
Thank you. And now we move with our next speaker. We welcome Mohamad Bahr from Finetech. So Mohamad, the floor is yours. You are muted, huh? Kilo.
So I just try to share my screen. Give me this 1 second. So now. Now you can see my screen.
Yeah, perfect.
Okay. Hello, everybody. My name is Mohamad Bahr. I am product management at Finetech, and today I'm going to present our plasma treatment module, what we have integrated in the last time in our system. So fast. Sorry. What's happened? So, before I start, I would like to introduce who Finetech is. Finetech is a German-based company who have been specialized in high precision die bonder equipment for more than 13 years.
Sorry, Mohamad, we can't see your screen.
Okay, sorry. So what's happened? Let me just try again.
It was working, huh? Just before.
Okay. What's happened? Can you see it now?
Okay, all good. You can.
Perfect. Thank you for let me know. Okay. Then before I start, I would like to just to introduce our company, who is Finetech. Finetech is German-based company who have been specialized in high precision die bonding equipment for more than 13 years. We have built a deep expertise from process develop to machine design and manufacturing. And we have built and installed more than 1,000 machines worldwide. We continue support our customer from early stage by development up to final product and serial product. Our platform offers 3 different machine types designed for different steps of the die bonding journey. We have our manual system being designed for ideal for early research and development, compact and easy to use. Then we have our semi-automated system built for prototyping and low value run. improve the alignment of the system. And then we have our full automated system for pilot lines and small to mid production with very high accuracy thanks to advanced pattern recognition and our software. The automated system being designed to be for long time process stability, and with minimal operator input. What you can do with our machine, we can offer different kind of bonding technology inside our system. Thanks to the flexibility of our machine, it can handle multiple bonding technology in one single system. That means you can have one system and use different kind of bonding technology, started by timber compression bonding for flip chip, multi-die stacking, automatic bonding, laser activation, laser assistant bonding, soldering, timber compression bonding, indium interconnected, adhesive bonding, and much more technology. To keep this flexibility and the possibility to use different kind of the bonding technology inside our machine, we decide after discuss with our industrial partner and our market research to integrate our plasma treatment in our system, because we see that the requirement for high clean surface and activation of module for hybrid bonding and advanced packaging become more and more important. And that was the starting point of integrated the plasma treatment. That's the benefit of the plasma treatment is that you can improve the bond performance and the results after using the plasma treatment for the adhesive bonding and hybrid bonding become much better. The surface cleanness for using different kind of material, it's also necessary by one of or another bonding technology. Which kind of plasma treatment decide Finetech to integrate it in our system? We have decided to integrate it patent atmospheric plasma using argon technology and integrated all of the system in our die bonder. You can see on the left side the plasma head who can be integrated and controlled by our system. The argon is the carrying gas to carrying and isolate the plasma from the source environment. The plasma gas can be different, depend on the application. We have argon oxygen plasma to clean organic. We have argon with hydrogen for reduce oxide layer on indium or another material, for example. The plasma temperature it's lower than 17 degrees, what allow us to use the plasma technology with very sensitive device without have to think about destroying this device. And this plasma treatment it's compatible with the semiconductor requirement. I will show you at the end one small video how the plasma module work in our machine. The benefit of integrated the plasma treatment inside the die bonder is that you can control the time between the cleaning, activation, and the bonding process. You can switch between different kind of gas, argon, oxygen, and or argon with hydrogen. You don't have to move the material between different kind of machine, and you save some space inside the clean room. Some user case where the plasma treatment been necessary to use. We have the hybrid bonding, what I point out at the beginning. We have the direct bonding, where the surface activation important is. By diffusion bonding, when we try to bond material to material, it's the clean of the surface necessary is. That's the video what I would like to show you. You can see that the plasma head move up and down inside our machine, being control, and the stage will move in the behind of the head to clean or to activation the surface, and then can move to the placement arm to make the next step on the component. The summary of my presentation, what I would like to point out here, that the plasma technology become more and more important in the semiconductor, in the advanced packaging and hybrid bonding. Finetech solution for this mark request is that we integrated patent atmospheric plasma, who can be used for sensitive and normal component, using different kind of gas inside the plasma treatment, depend on the application. Thank you very much for your attention, and feel free to ask your question.
Thank you, Mohamad. Thank you very much. Any question for Mohamad? Okay, so if you have any further question after the meeting, you can contact me or contact Mohamad directly. Thank you again, Mohamad, for your presentation.
Thank you also.
Now, welcome our next speaker, Robert van Tankeren. You are co-founder and CEO at Inphocal. So, Robert, if you are here, yes, the floor is yours.
Perfect. Thank you. Good afternoon. My name is Robert van Tankeren, co-founder and CEO of Inphocal. Thank you for this opportunity to pitch our company to you today. Today, I'd like to tell you a bit more about our company, specifically who we are, what we do, and why I'm here. But let me start with the summary of it all. In short, we are Inphocal, a deep tech scale-up from Eindhoven with a revolutionary new optical technology. Our technology basically increases the efficiency of laser processing by several orders of magnitude. And as it stands now, we have a solid business plan, around 1 million in sales, growing towards 100 million in the next 5 years with a healthy product margin and a strong IP position. And I'm here today to tell you a bit more about our first ever product that is now being introduced into the market. But allow me to start with telling you a bit about our history. The concept of Inphocal started in 2018 when Martijn Boerkamp, at the time the CTO of the High-Tech Excel venture building program, went on a scout mission to the CERN Institute in Geneva to see if they had technology suited for the High-Tech Excel program. And when he saw what they had, he decided to actually quit his job at High-Tech Excel and join the program as a participant, because this was actually the technology that he had been waiting for himself. And in September 2019, Inphocal was officially founded. And at the beginning of 2020, the program managers of the program asked him to strengthen his team further with people with a sales and finance background. And that's when he approached me and Katie, our third co-founder and CFO. And after just one meeting, the three of us decided to actually take the leap and build our own company. And in the past 5 years, we've managed to develop the technology, build a prototype, and this year we went into selling fully certified systems. And as we speak, our first systems are now running in production lines, marking items with a unique and scannable QR code at a speed of 3,000 items per minute with a yield of over 99%. Now, as many of you know, the laser market itself is already a really big market, valued at over 24 billion. Our beachhead market within this is the marking in the food and beverage industry. And while laser technology has been around for quite some time, no real innovation to the technology itself has been done in this period. If you take the food and beverage industry as an example, ink is still the dominant technology used for marking items with an expiration date or any other form of identification, such as a QR code or 2D matrix. The problem with this is that it needs a consumable, causing unneeded pollution. It also requires almost continuous maintenance. And the end result, the quality still leaves much to be desired. And in searching for the alternative to this, the entire market has seen that only laser marking can do what needs to be done. But the problem is that even now, current laser systems cannot match the speed or the amount of print that inkjet can provide. And this is actually where we come in. With our patented optical technology, we can increase the focus depth of a laser beam. And the easiest way to explain this is by comparing it to a magnifying glass used to burn a hole in a piece of paper. If you use that, you need to position the paper exactly in the focus point of the magnifying glass. And moving it a bit up or a bit down, you can still see the light hitting the paper, but the light actually isn't burning that hole as efficiently anymore. Laser processes work in the exact same way. If you want to make a laser do anything with the object it's hitting, you need to focus the energy onto that object. But the problem is that the laser beam focus is really narrow and immediately defocuses afterwards. So you have a really small window in which that laser beam can do what needs to be done. But with our unique and patented optical technology, we can increase the focus area of that same laser beam by almost 20 times. And in doing so, we can create a system that no longer needs to refocus, can mark on much larger areas, also on curved surfaces, and has improved precision to mark on a large tolerances to movements. And that brings me to the actual reason that I'm here today. And with immense pride, I can now fully show you our first product, the F1MV, which you can see here. This is our first commercially available, fully certified system that can mark items up to 3,000 items per minute with a success rate of over 99%. Can be used for multiple applications within the food and beverage industry. This video shows that process happening. But while we focus our specific system, this F1MV, on entering the marking for the food and beverage industry, it's by no means the end of our scope. This is just the beachhead. And while we have already sold several systems and we are receiving orders from more global players in the industry, we are moving towards a platform technology. And while we keep our focus on entering one market at a time, we have actually already identified and patented our capabilities for the next market, which is to enter the semiconductor market. And this movie just shows you our proof of concept for our wafer dicing capability, matching the experimental results that we have with our simulations. But going back to the current market, to be able to mark individual products, either caps, cans, or bottles with a unique and scannable QR code has long been the wish from the food and beverage industry. But there was simply no technology available to do this in line with the production running at high speed. We can. And we use these insights gained from this to also start projects with global key players in the bottle enclosure business. Not only crown caps, but also plastic caps for water bottles, for instance. And due to our technology, we can also add scannable QR codes directly onto transparent PET material. So in summary, the benefits for our clients are very straightforward. They can capitalize on faster, more cost-efficient systems with a sustainable technology and allowing for new feature enablement. And while we're extremely proud of the company that we've built, it's fair to say that we are even more proud of the team behind it. We've managed to build an incredible, diverse, international team of over 20 people with over 13 different nationalities and with a ratio of men to women close to 50-50. We have a mix of young engineers and experienced leaders. And that's my story to you today. Thank you so much for listening. We are Inphocal, and this is Light Without Limits.
Thank you, Robert, for this interesting presentation. Any question for Robert?
Hello, this is Holger
Hello.
from IHB. I just want to quickly remind you, IHB is your provider of packaging. So whenever you want to look for a package for your sensor, for your laser, then please contact to us. That is for my, and I think, Robert, you are also using this kind of product somewhere. So I would be pleased to see an inquiry coming forward.
That sounds good. I will definitely contact you later.
And this is not only for you, Robert, but for all of the people attending to this kind of this meeting today.
Okay, any question for Robert? Robert, you mentioned different kind of application. So where would you like to be used actually? Because you mentioned many use the food and beverage industry, but do you have any other kind of market you would like to target?
Yeah, we're currently looking into the semiconductor industry, but we've also had some interest and we have started some talks regarding to laser welding and laser cutting. So like I said, the technology itself in essence is the same, but just with different applications. But as we are a scale-up with a limited amount of resources, we can only move into one market at a time. So any other market that we want to go into, we will either need a partner to help with financing the first prototyping, or indeed have a customer already lined up to buy the system and then build it together with us. But we are definitely moving towards different markets.
Okay, and for the system integration, how do you work? You work directly with the customer, or you externalize the system integration process?
We build our own fully certified systems, and we will install them with the cooperation of our field service team. And then depending on what the customer would like, we can also do service licensing agreements and maintenance schedules and predictive maintenance to make sure that the product is up and running. And we do integrate it indeed into their production line.
Okay, so you do it. Okay, perfect. Thank you, Robert. Thank you very much.
Thank you.
Now let's welcome our next speaker, David Cardador Maza from Mapsi. David, yes, you are here.
Yeah. Hello.
Hello.
You hear me well?
Yes.
Okay, so I start. So yes, I am David, and together with Danny, we co-founded Mapsi in 2021. But what's Mapsi? Mapsi, we are manufacturers of infrared filters for mainly industrial applications, but not only. Also, we work with other applications like biotech or astronomy. And it's important to say that we are designers and manufacturers with our own and proprietary manufacturing plant. Here you can see one of our machines, and we produce those filters with a disruptive technology. Some of you maybe know, you already know about our technology, but those that don't, I will explain a little bit. Usually, current technology of filters in infrared or visible or near infrared, whatever, are multi-layer. So they are done by the deposition of multiple layers, one above another, above a substrate. And when you're going to target gas inspection or process monitoring in the infrared region, mid-infrared, long infrared, those layers depends on and rely on germanium, for example, indium, tellurium, which are restricted materials, or rare materials, and also the thickness of those layers are high, they are thick. So they have some optical low performance. Because of this, they delaminate when they are exposed to temperature, to humidity, etc. So we decided, okay, if the problems are the layers and the materials and so on, so let's avoid the layers. And this is what we do. We avoid layers, and just by performing some holes in a substrate and controlling the geometry, which is not easy at all, you can somehow change the contrast index of the refractive index, sorry, so that you can optimize the optical performance, resolution, and blocking range, etc. Also, you are doing it with silicon, so it's really robust. It can withstand really high temperatures, corrosive environments, and also high humidity environments. And this is why we are focused in industrial applications because of this. And it's important to say that we save 70% of the energy compared to the competitors, because we are using a chemical process, not a energetic process like the multi-layers. So this is how we compare with no, sorry. Those are the products that we already are marketing. So bandpass filters and windows. So it can be in bandpass filters either long and broad bandpass filters or narrow bandpass filters. And windows high transmission from 1 micron to 12 microns. This is how we compare now. This is the slide. This is how we compare with in Windows with the competitors. You can see this Mapsi is totally flat. The others are not. And what is important, and it cannot be seen here, but it will be in the next slide, is that we are angular independent. And if you hit the filter, you don't lose your optical performance. And this is quite an interesting property of our filters. And you can see here that the mechanical robustness, when one of our filters and one of the competitors are heated up to 350 degrees for more than 30 seconds, ours remain the same, and multi-layers, they start delaminating. So this is why we say that we are more robust. Here you can see the comparison of the angular dependency. That means that depending on the degrees of the impinging light to the filter, you have another one or another optical response. Here from 0 to 30 degrees. Our competitors, you can see a shift towards left, lower wavelengths, and also a decrease of the transmission. Our filters, when they are not optimized at all, they have lower excursion and lower transmission decrease. But when they are optimized, you can see the big difference in between the competitors. This is something interesting for recalibration of NDIR gas sensing, for example, or thermal cameras. And we are now progressing quite a lot, and we are going to hopefully avoid or minimize a lot, even more than this, the optical, the angular response. We have developed really recently, and we are proud to say that we have developed long infrared filters in the very low wavelength. So from 10 to 14, it was a challenging, really challenging to us, filters, design, and optical and mechanical, and we succeeded, and this is something really interesting. So if you have and you want to any filter from 10 to 14 with high specifications, please contact us. And ultra thin filters for crystal sorting and gas sensing, you can see them here. They are 0.25 to 0.3 millimeters thick, and this also, it's interesting for compact devices, for TO8 or SMD packaging. And if you like, you can consult our catalog. And if you like some of our filters, you can here you have a QR. So if you order one of those filters, you will enjoy a 25% of discount. So hopefully we will hear from you, and thank you very much for listening now.
Thank you, David. Thank you very much for your presentation. Any question for David? Okay, so thank you, David. Thank you very much. Thanks a lot. And now we can move on with our next speaker, Matthew Anderson from Wave Photonics. Matthew.
Hello, good afternoon,
Yes,
everyone.
hello.
Let me just share my screen. So hopefully everyone can see the screen.
Not yet. Yes, all good.
Awesome. Hi, good afternoon, everyone. I'm Matt, one of the co-founders at Wave Photonics, and we're a startup based in Cambridge, doing photonic integrated circuit design, enabling rapid development for any platform or wavelength. And today I'd like to give a brief demo of a recent product that we've launched, which is the PDK management platform. And so this is really something that we've developed that's leveraging some of the internal capabilities to smoothen and reduce sort of barriers to entry for customers and looking to get started with photonic design and how they can access Foundry PDKs. So today I'll quickly present this, and then I'll jump into a live demo of the platform itself. And what I'll show is first what the Foundry experience looks like in terms of how they can upload a PDK to the platform. Then take a look at sort of the designer experience and how they see the platform and can access that PDK, and then sort of the designer Foundry interaction in terms of how a designer can access a PDK that might be controlled by an NDA. And so just to provide a bit of an overview of what this platform really is, it's essentially leveraging a lot of the internal capability we developed that we were initially using ourselves in order to distribute the design libraries that we design and optimize for different foundry processes, and the desire to make them accessible in many of the different EDA tools that people use when they're designing photonic integrated circuits. So having different compatibilities with the different EDA tools, but then also looking at how can we black box those designs for IP protection and being able to swap them out before fabrication, having S parameters and compact models generated for all those building blocks in the PDKs, such that you can do circuit design and simulation out of the box, and then having all of the documentation for that PDK automatically generated. And so the pipeline that we developed is sort of automated this process where we take a PDK, we can then generate the compact models, generate the plugins for all of those different EDA tools that we support, with all the documentation there as well, and then push that to the website platform for users to access in a kind of fine-grained permissions control way that hopefully that makes it smoother for the customers to access different foundry PDKs. So with that, let me jump into the live demo. So hopefully you can see now two web pages that look identical side by side. And on the left-hand side, we have sort of the demo of our demo fab. And firstly, I'll just show how easy it is for a fab to sort of upload that design and send it through this internal pipeline that we've developed. So as a fab user, when they've signed up, they simply go to the PDK uploader page, and they'll be able to see at the bottom, there's the PDK upload. Here, there's then just a drag and drop box where they can drag a zip file where the PDK has been put into a particular template format that we've developed, and we can help the fab put their PDK into that format initially. We've also made it so you can download that, and there are some instructions that enable and guide you through that process. You then can just upload that. In the background, it runs a series of validations and checks to make sure everything's correctly formatted in the right place. And when those validations have run, you'll see that it's updated and it's now ready to submit to the Wave platform, and then it'll run through this pipeline to generate the compact models, to generate the different EDA plugins, and push those to the website as a PDK. Now, on the right-hand side, from a designer's perspective, for how they look to access these different design libraries, they simply navigate to the hub, which on the website is where they can see the different foundries that have PDKs available on the platform. They'll be able to then access the foundry where they want to see the PDK. And in this context, they'll be able to see the different PDKs that fab has available, and you'll see that there are different NDA flags determining whether it's accessible or not. In the case of sort of open source PDKs, like Cornerstone, for example, there's a research fab in the UK, you can simply request access, and you'll see that it's immediately being granted, and so that user can now access that library directly. However, if there is an NDA required to be signed before accessing that design library, for example, with the sync PDK that might be available, and this is a feature of our previous product release, which was a silicon nitride photonic design library that we put together, covering wavelengths from down near the UV at 493 up until 1550 on a 200 nanometer silicon nitride process that's available at Cornerstone. But for example, here, if this is protected by NDA, the user can simply request access to that, confirm that they know what they're requesting, and then on the fab side, they'll see in their managed PDK sharing portal that the request has come in. The notifications are sent on email to inform that this is being requested and that this process needs an NDA to be signed. When all of the documentation is being completed, the fab can then go in and happy that they've confirmed that the NDA is being signed, they're then able to progress and grant access to that particular organization for that PDK. Back on the user side, that PDK then appears in their PDK table, and now they're able to view that PDK, select which of the different EDA tools that they'd like to use it in. So in this example, we can look at Lucida IPCIS. They'll be able to download the package, which will download as a zip file, and they'll also be able to view the documentation that's available for that PDK, which is all automatically generated. And for example, they'll be able to access information around the different ADKs or the assembly design kits that are included by default for the PDKs that we run through the platform. So for example, here there's the QPickPack ADK, which was a template co-designed with Alta Technologies, and provides the templates in the design phase to enable sort of a known prototype packaging. And so with that, the last thing I'd like to just show is the ease of use in terms of installing one of these PDKs. So for example, we have Lucida Control Center here, and simply to install this PDK to work with Lucida, we can just go to Design Kits, we can add it, navigate to where that zip file was downloaded, you can then open it, and this will install that PDK in Lucida's environment, and you'll be ready to go for your circuit design, and you'll be able to run the circuit models and S parameters and sort of design and circuit simulation straight away. So you can see that's already installed, and now a design is ready to go. So that's everything I'd like to show in terms of the PDK management platform. Please reach out to us if you're interested, and we can give further information and demos. And yeah, so the idea here is that we're really trying to improve the Foundry user experience and sort of bring down those barriers to getting started doing design in photonic integrated circuits. Thank you very much.
Thank you, Matthew. Thank you very much. Any question for Matthew? So Matthew, how the license is working? Do you take do you say a monthly license for companies, or how do they access to the platform?
So right now, as a designer, you can simply sign up and access the different PDKs that are available on there. From the Foundry user side, in order to have the PDK hosted onto the platform, that requires a kind of cost associated with operating that, and that's something that we can speak to with the different foundries that are interested. But as a user of the platform right now, you can sign up and access those PDKs that are available on there.
Okay, thanks. Any question? And if not, thank you again, Matthew.
Thank you very much.
And I would like, before to finish, I would like to thank all the speakers today, of course. And if you have any further question the next few days, next few weeks, feel free to contact us. You can also already answer the poll right now. And yes, I tell you, see you in another epic meeting. Thank you very much for your participation. Goodbye, YouTube.
Bye.
Bye. Goodbye.